The paper introduces Croissant-RAI, a machine-readable dataset documentation format designed for responsible AI. It builds upon existing frameworks, such as Croissant, to enhance discoverability, interoperability, and trustworthiness of AI datasets. Croissant-RAI extends the Croissant metadata format, incorporating attributes and practices for community-wide adoption. It leverages web publishing practices like schema.org and is integrated into major data search engines, repositories, and machine learning frameworks. The format was developed through a community-led effort, focusing on evolving documentation requirements. It includes a Python library and a visual editor for user assistance. The paper discusses the background on machine-readable metadata, the Croissant format, and state-of-the-art RAI documentation frameworks. It also presents the vocabulary engineering process and use cases central to Croissant-RAI, along with dataset examples demonstrating its use. The research paper discusses the development of Croissant-RAI, a machine-readable metadata format for ML-ready datasets. It begins with the multi-step vocabulary engineering process, involving bi-weekly sprint sessions, stakeholder engagement, and brainstorming to define use cases. This process includes comparisons with existing dataset documentation vocabularies, scope definition through competency questions, and conceptualization of the RAI extension. The implementation involves bi-weekly sprint cycles to develop the conceptual models and operationalize core features. The evaluation phase includes annotating popular datasets to ensure effectiveness and usability. The Croissant-RAI format extends schema.org with additional layers describing datasets' attributes, resources, structure, and semantics, facilitating their use and sharing within the ML community. It addresses the need for machine-readable metadata formats in the ML community, enhancing discoverability, portability, and reproducibility of ML datasets. The paper highlights the importance of data documentation in developing fairer and more trustworthy AI applications, proposing a machine-readable framework for capturing RAI data documentation practices. The Croissant-RAI vocabulary is an extension of the Croissant and schema.org datasets, focusing on responsible AI practices and data standardization. It was developed through a collaborative engineering process involving stakeholders from various domains. The vocabulary includes attributes for 5 use cases: data lifecycle, data labeling, participatory data, AI safety and fairness evaluation, and regulatory compliance. In the data lifecycle use case, the Croissant-RAI extension adds details about the data collection process, design assumptions, data use cases, and identified limitations. For data labeling, it offers attributes to ensure label quality, including annotation process and annotator information. For participatory data, it documents information about data collectors, their demographics, and the platforms they use. For AI safety and fairness evaluation, the vocabulary aids in identifying potential risks and fairness aspects of data usage. It includes attributes for known and intended usage, such as adversarial datasets for safety evaluation and counterfactual annotations for fairness evaluation. Lastly, for regulatory compliance, it allows users to annotate information relevant to privacy and regulation laws, including sensitive and personal identifiable information, data governance, and security measures, and data sharing agreements. The vocabulary is structured to be scalable to other domain-specific extensions in the future. It incorporates both core Croissant and schema.org properties, as well as new properties defined specifically for the RAI extension. A detailed description of each property of the vocabulary is provided in the appendix. The Croissant-RAI vocabulary is a novel approach to annotating AI datasets, focusing on the ethical and societal implications of data collection, processing, and utilization. It provides a comprehensive framework for describing datasets in a structured and standardized manner, encompassing various aspects such as data limitations, biases, manipulation protocols, and annotator demographics. This paper presents 3 diverse datasets: HLS Bern-Scar scenes, DICES 350, and Big Science Roots corpus, each with its unique characteristics and challenges. The HLS Bern-Scar scenes dataset, described in Listing 1, is an AI-ready geospatial dataset comprising satellite imagery used for detecting burn scars. It includes information on data collection, preprocessing, and data limitations. For instance, it highlights the importance of location accuracy and spatial properties in geo-AI datasets, which can significantly impact AI predictions. The DICE's 350 dataset, shown in Listing 2, is designed for evaluating conversational AI model safety. It emphasizes the need for nuanced safety evaluation, focusing on diverse perspectives in model training and assessment. This dataset ensures balanced demographic representation among raters and assesses safety across 5 categories, including harm, bias, misinformation, politics, and safety policy violations. The Big Science Roots Corpus dataset, mentioned in Listing 3, is a community-created text dataset used to train one of the most recent open-source large language models. It includes several data limitations and biases, such as overrepresentation of pornographic text and reliance on medium to large sources of digitized content, which may overrepresent privileged voices and language varieties. The Croissant-RAI format encourages data authors to reason about their data with a specific schema in mind, akin to structure of proposals such as datasheets for datasets. This schema can be used to describe various datasets, including geospatial, conversational, and text datasets, providing a comprehensive understanding of the data and its implications for AI model development and deployment. The paper discusses the development of Croissant-RAI, a machine-readable format for capturing and publishing responsible AI, RAI, documentation metadata for AI datasets. This format is designed to facilitate the sharing, discovery, and reuse of RAI information in datasets, thereby promoting responsible AI practices. The authors emphasize the importance of integrating RAI benchmarks into frameworks to foster higher data quality standards and encourage further research in this field. The paper also highlights the Big Science Roots Corpus dataset, a large-scale multilingual dataset used to train the Big Science Large Open Science Open Access Multilingual (BLOOM) language model. This dataset has inherent variability due to its diverse sources, which can lead to inherited limitations and biases. The authors provide an overview of the pre-processing steps applied to ensure data quality. Moreover, the paper presents several other datasets and tools that support the development of Croissant-RAI, such as the DICE's dataset for evaluating conversational AI safety, crowdworksheets for accounting for individual and collective identities underlying crowdsourced dataset annotation, and the FAIR guiding principles for scientific data management and stewardship. The authors also discuss the need for data-centric machine learning research, as well as the importance of navigating dataset documentations in AI. They mention various tools and initiatives aimed at promoting data quality and responsible AI practices, including the Croissant Python library and its web UI editor, which allows users to input RAI attributes in JSONLD form. In conclusion, the paper presents Croissant-RAI as a significant step towards enhancing the transparency and accountability of AI datasets. It highlights the importance of responsible AI practices and the need for high-quality datasets that can help mitigate system bias and foster better science. The authors emphasize the role of community engagement and collaboration with public and private partners to ensure the widespread adoption of RAI methodologies and their responsible implementation. The summary begins with an overview of the data collection process, including types of data collection and descriptions of missing data. It then delves into data preprocessing, focusing on protocols for handling missing data, data manipulation, and data preprocessing. The importance of data annotation is highlighted, discussing various aspects such as annotation protocols, platforms, and considerations for converting raw annotations into labels. The section on data release maintenance includes versioning information, while discussions on personal sensitive information, social impact, biases, limitations, and use cases are also covered. Finally, the summary touches on the number of annotations per item, annotator demographics, and machine annotation tools used. Throughout, technical terms and concepts are explained with precision, highlighting the significance of each component in the data lifecycle.